Hello everyone. Today we are going to be going over notes on metallic bonding. So just as a review, remember for every type of bond, we want to know three things about it. So remember the first thing is what elements. The second thing is what happens to the electrons. And the third, what's the force holding it together. So let's go through this slide on metallic bonds and identify what each of these things is. So first, for what element? So as I read through, I'm going to be looking for like metal, non-metal, or metalloid here. So it says there's an electrostatic attraction between the free moving valence electrons and positively charged metal cations. Now this makes sense that a metallic bond is made of metals, right? So when you're looking at any compound that is only metal atoms, that would be a metallic bond. Now for what's happening to electrons, if we look at what's happening to the electrons, it describes in here that the electrons are free moving valence electrons. Now that's pictured in here with all of our yellow dots, right? All of these are not attached to an atom. They're just free to float around wherever they want to go between each of those metal cations. So all the electrons have just been lost and now they're freely floating around. Now the last part is what's the force holding all of this together? So the force holding everything together, it says, is the electrostatic attraction between the electrons and the positively charged cations. So the electrons that are moving around are like glue, holding all of these metal cations together. So we have that glue attaching everything to each other. So now that we've gone over what the three things holding a metallic bond, or the three things we need to know, I also just want to do a quick review of covalent bonds and ionic bonds. So remember, for covalent bonds, let's hope my screen will load here. There we go. Are made of only nonmetals, and those nonmetals share the electrons. The attraction is between the positive nucleus to electrons of the other atom. And then for ionic, remember, this is where a metal gives up an electron, and the nonmetal takes that electron. So we have both metals and nonmetals. The electrons are being transferred from one to the other, and the force holding it together is the attraction between oppositely charged ions. So I have a positively charged cation, negatively charged anion. All right, so now let's go back to metallic. So again, metallic, it's only metals, it's freely moving valence electrons, and the attraction or the force holding it together is the negatively charged electrons to the positively charged metal cations. Let's go ahead and continue on to the next part. So this next slide describes the bonding in gold. So here we're showing the core electrons and the nuclei. These are the metal cations, right? So all the core electrons don't move, and the nucleus doesn't move. But they have this sea of electrons. So we have these valent shell orbitals that can travel throughout the metal. So they're no longer attached to the nucleus. They're just freely flowing. Now, this is called a sea of electrons. So it's freely flowing just like the ocean, right? So just like water can flow around the entire world in a wave in the ocean, in an atom, in a metallic bond, the electrons are free to move around. Now, what I want you to try and think about next. Why do metals have a sea of delocalized electrons? So electrons that are free to flow around and move, whereas in like a non-metal atom, the electrons are not free to flow around and move. So I want you to think about electronegativity as you come up with an explanation. So go ahead, pause the video right now, and then once you have your answer, you can hit play again. All right, so in terms of electronegativity, let's refresh our memory here. Remember, the metals are on the left side of the periodic table over here. So we're trying to think about each of these elements. Now, all of the metals have lower electronegativities. So that means that they hold onto their electrons very weakly. So because they hold onto their electrons very weakly, it's likely that they will have that sea of electrons. They're holding onto the electrons weakly. So they can flow freely. Since there's no force holding them on, they're free to move. Okay, so now let's talk about alloys. So far what we've been talking about is like pure element metals. So for example, this is just like pure gold. So that's only elements of AU. There's no other elements present. Now we're going to be talking about alloys. So an alloy is a mixture of metal elements. So it can be a mixture of a metal with other metals, or it can also be with other metalloids. So it can be metal with metal or with metalloids present. Now, there are two types of alloys that we need to know about here. The first is a substitutional alloy. So in a substitutional alloy, that's what's pictured in the middle here. So this alloy has atoms or second elements that are put in that have a similar atomic radius. So notice that in the pure metal, it's all red. But in the substitutional alloy, we have red dots and blue dots that are of a similar size. So all that happened is in this third spot here, we got rid of this red atom and replaced it with a blue one. And because they're a similar atomic radius, this would mean that it just replaces it. It takes its spot. Now, this is different than what's called an interstitial alloy. In an interstitial alloy, you have small atoms that fit between the main atoms. So again, looking at our interstitial, we started with all red. Now in the interstitial down here, we still have all those red atoms. But now we also have these green atoms that are in between. Now interstitial, if we break down that word into parts, inter just means between. So like international travel, right? It means travel between two nations, all right? So stitial just means space. So it's an alloy where there's stuff between the spaces, okay? So we have stuff that is between each atom here that allows it to form this new type of alloy. Now, for this class, you need to know what, or how to identify types of alloys based on some image. So for example, here, I want you to try and label each one as a substitutional alloy or a interstitial alloy. So go ahead and try that, pause the video now, and when you're ready, go ahead and hit play. All right, let's go ahead and review our answer here. So on the left-hand side, each of our green atoms was just replaced by a brown atom or an orange atom. So the nickel was just replaced by copper, so that means it was substituted. Just like you have a substitute teacher right now taking my place, who is similar in their abilities, this is similar to a substitutional alloy, right? There is a green atom that just got substituted by the orange one. Now, if we look on this side, in this one, it doesn't look like there's any substitutes, right? There's no orange that was taken over by a green. It's just that there's these little dots in between each of our atoms. So because we have these smaller ones in between, this would be interstitial. Okay, let's go ahead and continue. Now, the last part here is, remember this whole module, the goal was to understand what is in your phone. So when we first read through the article, maybe you were a little bit confused about what was present. Now, hopefully it makes a little bit more sense, right? We have some things that are pure metals. We have other things that are ionic. We have other things that are covalent. So now you can go back through, try and read through and try and identify which of these things are ionic, what are covalent, what are metallic. All right, that's where we're going to stop our notes for today. At this point, you're going to move on to have some time to work on the analysis questions for the metallic bonding lab. So go ahead and start working on the analysis questions for the metallic bonding lab. You'll have till the end of the period to work, and then tomorrow we have our review day for your quiz. If you finish the analysis questions for the metallic bonding lab early, please go ahead and start working on creating your cheat sheet for the review. So you can start scrolling back through your notes here and writing down things that you think will be important. Some things that might be useful. Having the 3 questions answered for your types of bonds. What elements make them up? What happens to the electrons? And what force holds them together? Some other things that would be valuable to put on here are some examples of writing formulas for ionic compounds and then drawing dot structures for ionic compounds like we have right here. And then you could also have examples of drawing covalent dot structures like we have here and here. So having some examples of how to do all those would be valuable to have there. All right, enjoy the rest of the period. Make sure you behave for the sub, and then I'll see you all tomorrow. Thank you, everyone.